Welcome back. In this next section, we're going to take a deeper dive into the mechanics of blockchain and how all this works. So let's start off with a pretty big question. Remember, in our last section, we talked about Yap Island and the economy of giant stone coins and how a collective mental ledger, a decentralized ledger, was managed by everyone on the island. We might be thinking to yourself, if all this was such a great idea, why is it something that we as humans only tried once 3,000 years ago and then completely abandoned the approach? Why haven't we adopted this idea since? And if you think about taking the approach that was used on Yap Island and using it in the modern global economy, there are two big problems that likely jump out at you. The first is simply the scalability problem. Human beings are fairly limited in the amount of data we can manage in our heads at once. That's why, really, anywhere you go in the world, you'll find that most phone numbers are between 7 to 10 digits long. As soon as you get more information than that, that's simply more data than a human being can keep in their head simultaneously. And even if we introduce more modern tools into the mix, if we start keeping this information on pen and paper or Excel spreadsheets or access databases, this is still a very, very difficult system to scale because of the inherent inefficiency. In other words, it is the inefficiency of the decentralized ledger that has really prevented scaling it up to global network sizes up until this point. Now, the second big concern that probably jumps into your head if you think about using the Yap Island system today is that of privacy. You see, on Yap Island, everybody knew mentally who owned which of the coins around the island, which is another way of saying that everybody on the island knew the personal bank account balance or personal net worth of everybody else at all times. And 3,000 years ago, on a small island of a few hundred inhabitants, each of whom spends their entire life together, this was likely not a problem. There likely wasn't that much privacy to be given away to begin with. But in today's modern global economy, with almost 8 billion individual participants, the vast majority of whom you will never see or meet or interact with face to face, this is a much larger concern. And so the story of blockchain is really one of how do we take this 3,000-year-old idea and breathe new life into it while addressing these big concerns around scalability and privacy. Let's start off with scalability. Really, this problem is one we've only solved by waiting out the clock. It has really only been within the last decade or so that computing power, storage space, and network bandwidth have finally become cheap enough and ubiquitous enough that we can start to pursue these very inefficient solution architectures at scale. And oftentimes we take for granted just how fast our computing technology has advanced in such a relatively short period of time. So to put this all in perspective, the good folks at jalopnik.com did an analysis a few years back comparing a 35-year time span between 1982 and 2017, showing the advancements both in personal computers and in the automotive industry. And the delta is pretty shocking. So let's start off looking at the advancements in personal computing technology. In this example, they used an Apple. So in 1982, you could go out and buy an Apple IIe. In 2017, you could go out and buy a new Apple iMac. If we look at some of the differences in what you get for your money over that 35-year time period, it's pretty staggering. You're getting over 160,000 times more memory. You are getting a machine that is 1,600 times faster. You are getting a computer that has over 7.5 million times more storage space. And you're doing all of this for about a quarter of the price when adjusted for inflation. If we look at the Ford Mustang over that same time period, the results are not nearly as spectacular. You can see that fuel economy has actually gone down slightly. And that is largely to do with the fact that the Ford Mustang 35 years later now comes with 3.5 times more horsepower. This gets it up to cruising speed about 3 times faster, but you're going to pay a little bit more in inflation-adjusted dollars, about 1.5 times the price you would have paid for this vehicle 35 years ago. So what if automobiles had advanced at the pace of computers? Well, that 2017 Ford Mustang would look quite a bit different. First of all, it would be packing a little over 660 million horsepower under the hood. That would get you up to cruising speed in a few 10,000ths of a second. And you wouldn't need to worry about stopping and filling up too much because you'd be getting a little over 3.6 million miles to a gallon of gasoline. And all of this driving pleasure could be yours for slightly under $4,500. So when you look at these advancements in terms of something different like an automobile, it becomes apparent that in a relatively short period of time, our computing technology has become orders of magnitude cheaper, more efficient, and more available. And that has led us to start pursuing and investigating some of these inefficient solution architectures. And all of this kind of dovetails with a very interesting quest that started in the mid to late 70s to design a workable digital currency. And there were many attempts, starting in the mid to late 70s, all the way up until 2009, to create a truly digital currency. And there were a lot of tough problems and challenges in getting all this to work, but far and away the biggest one was something called the double spend problem. And that is a problem that arises because if you're asking a computer to manage a digital currency, you're asking it to do something that is the antithesis of what it was designed for. You see, we've designed all of our modern technology to make it remarkably easy to copy and share data. Think about taking a picture. Let's say you're out walking around one day and you see something interesting happening in the world. So you pull out your smartphone and you take a picture. So now that image lives on your phone. You then decide you want to share that picture with some of your friends. So you text it to a couple close friends and family members. Now there's a copy of that picture on your phone and another copy of that picture on my phone and on everybody else's phone that you texted that image to. Then maybe you decide you want to share that picture with even more people. So you decide to post it on your Facebook page. And if someone is scrolling through their news feed and they come across your picture, well, now there's a copy of that image in their browser cache. And there's a copy of that image sitting on Facebook servers in a data center somewhere. And this is nothing more than our technology doing exactly what we've designed it to do, making it seamless and thoughtless to copy and share information. And all of this works great until you start talking about a currency. Because one of the things that gives currency value is scarcity. And if anybody can go copy and distribute a currency anytime they want, well, that's really going to destroy the value of this. And this is something called the double spend problem. How do you prevent a digital asset from being consumed more than once? And there were many attempts at making this work over this time period. And the one that got the closest to actually being functional was an attempt in the mid to late 90s called BitGold. And BitGold actually defined and introduced a lot of the paradigms that would later go on to be Bitcoin. BitGold wasn't fully successful, but it really did set the stage and the foundation for Bitcoin. In 2009, the double spend problem was solved. And this long-standing quest, this 30-plus year quest to create a workable digital currency had finally come to an end. And the world's first blockchain, Bitcoin, goes live. So understand, in 2009, when Bitcoin goes live, the view of blockchain is very, very myopic. We just saw blockchain as an enabling component to finally make digital money work. So Bitcoin is all about using blockchain to track and manage the history of just one asset, just one thing that we care about. And those things are Bitcoins. Now, Bitcoin gives us one single shared ledger per network. There are many copies of this ledger, but we're only working on one set of data. And this is tremendously important for any platform like Bitcoin, which offers a built-in currency. If we had more than one ledger, things would get problematic. Imagine if I had a Bitcoin wallet with 5 Bitcoin in it. And I had 2 friends, Alice and Bob, and I owed both of them a debt of 5 Bitcoin. Well, let's say Ledger 1 says I paid Alice, and Ledger 2 says I paid Bob. Well, who got paid and who's going to go home unhappy? It's impossible to tell. So in order to avoid that pitfall, we only support one single shared ledger per network. And Bitcoin is what we talk about as a blockchain 1.0 platform, meaning it is just a ledger. It's just a way to record data. There's nothing more you can do with it. This idea of smart contracts, of being able to define your own actions, this did not come around till later. Now, Bitcoin is very highly anonymous, and that means all of the data is fully transparent. So we can look at a sample Bitcoin transaction. Anybody out in the world with an internet connection could go view this same transaction. And what we're seeing here is that on a certain date and time, May 22nd, 2019, a transaction was initiated from one wallet or account, the account on the left, to the account on the right. And we can see that just under 0.05 Bitcoin was sent from one account to another. Now, it is very, very difficult to figure out who are the human beings behind these accounts. Bitcoin makes all of this data very highly anonymous. And imagine if I owed you some money and we banked at the same bank, so I just made an electronic transfer from my account to your account. Well, internally, the bank will keep a ledger that will contain that transaction. And if you imagine what would be on the bank's internal ledger, it really would be nothing different than what you see on my screen right now. The only difference would be the identities of the individual participants would be known. In a Bitcoin transaction, we make no attempt to track or maintain or manage the identities of these participants. All right, so that was 2009. Fast forward 6 years, and now we're in July 2015. And a big name in the blockchain space goes live, a new platform called Ethereum. So 6 years in, Bitcoin was starting to get some traction, and people were taking notice. And they saw that there were some pretty interesting things, potentially, that you could do with blockchain. They also saw that there were lots of areas where the Bitcoin model could be extended and enhanced, where we could start to do new things with blockchain. And that is really the story of Ethereum. It is a platform that picks up where Bitcoin left off. It picks up on a lot of the same ideas and concepts as Bitcoin and then extends that model. So Ethereum just like Bitcoin has its own built-in currency. The currency on the Bitcoin blockchain is called Bitcoin. The currency on the Ethereum blockchain is called Ether. And these are nothing more than just two different types of currency. Imagine if I owed you some money and I pulled out my wallet, and inside my wallet I had some US dollars and some Canadian dollars and some Japanese yen and some European euros and some British pounds. All of those currencies would function the same, and I could pay my debt to you in whatever currency you like. They all work the same, they're just different types of the same thing. Well, that's what Ether and Bitcoin are, just two different types of currency. Where Ethereum started to extend the Bitcoin model is Ethereum says, okay, we'll give you a ledger that you can use to track any kind of asset. You can keep track of anything that you care about, not just Ether changing hands back and forth. So on the Ethereum blockchain, I can record the fact that I paid you some Ether, I sent you some money. I can also record the fact that my sports team beat your sports team in the big game last night, 13-3. You could record that the high temperature at your house yesterday was 28 degrees centigrade. We can record other types of information, not just information about Ether exchanges. Now, because there's a currency involved, we still have one of the same limitations that Bitcoin had, that being that we can only have one single shared ledger per network. Again, we have many copies of this ledger being maintained, but we're only keeping one shared ledger. And again, this is to avoid any confusion around who got paid and who didn't. But perhaps Ethereum's biggest contribution to the blockchain world was it was Ethereum that introduced us to this idea of smart contracts. That now we could use blockchain not just to record the fact that something interesting happened, but we could actually take action on that event. We could programmatically respond to information that got recorded on the blockchain. And this fundamentally changes the way that we view the technology. Up until this point, blockchain is viewed as nothing more than just a record-keeping technology. With the addition of smart contracts, our understanding of blockchain evolves. And blockchain at this point becomes an application development platform. It becomes something that you can come design and build a user experience on top of. Now, Ethereum also introduced something known as the ERC20 token standard. And so to this day, Ethereum remains the platform of choice for any project, or use case that is enhanced with the use of a custom coin or token. Now, Ethereum, just like Bitcoin, maintains a high degree of anonymity for its users, and thus all of the data on Ethereum, just like Bitcoin, is fully transparent. And that is because identity is a prerequisite to permissioning. If I don't know who you are, the only real choice I have is to show all the data to anyone anytime they ask. So we can look at a couple different Ethereum transactions. We can look at a financial transaction. And here we see something very similar to what we saw with Bitcoin. Just a little bit of Ether being sent from one account to another. We can also look at a non-financial transaction as well. So here's an example of a smart contract that could be used to record votes in an election. And in this election, you can see we're voting to see who is the coolest person in Mike's class, and someone here has cast a vote for Oksana Davis. So no exchange of monetary value or Ether involved at all. All right, around this same time, late 2015, the second big name in the blockchain space goes live, a platform called Hyperledger. And just like the folks at Ethereum were looking at Bitcoin and saying, there's a lot of stuff we could do with blockchain. Let's extend the model. The folks over at Hyperledger were looking at blockchain and saying, you know what? There's a lot of interesting things here we could do in the enterprise space. This might be a great technology for building business applications on top of. And so Hyperledger is the start of blockchain for the enterprise. And we see some pretty significant differences here. First of all, there's no native currency. There's no Hyperledger coin. No one talks about going to an exchange and cashing out their Hyperledger, or what the price of Hyperledger has done over the last week. Just like Ethereum, we have a ledger that can be used to track and manage anything that we care about. But because we don't have this currency to worry about, we're no longer subject to the limitation of having just one ledger. Remember, on Bitcoin and Ethereum, we could only have a single shared ledger, because if we had more than one, it would be impossible to reconcile payments, who got paid and who didn't. Well, if we don't have to worry about reconciling payments, that limitation goes away. So Hyperledger supports multiple ledgers. Hyperledger also supports the idea of smart contracts, although in the Hyperledger ecosystem, we don't call them smart contracts, we call them chain code. But the idea, the concept, is absolutely identical. The other significant change in Hyperledger is that anonymity and full transparency go away. Anonymity is replaced with identity. The participant, or the identity of any participant on a Hyperledger network, is always known. And remember, identity is a prerequisite to permissioning. If I'm going to define and enforce permissions, I first have to know who everybody is. So let's combine some of these big changes, multiple ledgers along with identity and permissioning, and some interesting things start to happen. Let's say that you're doing business with several different suppliers, and all of you decide to record your transactions on Ethereum. Well, that means when you transact with supplier A, supplier B gets to see all the details. And that might not be desirable. Maybe you've negotiated a special low price with supplier A. And supplier A will only give you that price if you keep it quiet, because maybe they can't afford to give that price to everybody. Well, on something like Ethereum, that's going to be problematic because there's only one ledger, and all of the data on that ledger is fully transparent. Hyperledger starts to address that with multiple ledgers and permissioning. Now, if you're doing business with 3 different suppliers, you can set up 3 different ledgers, each with a different set of permissions. And all your transactions with supplier A are recorded on a separate ledger from your transactions with supplier B and supplier C. And the suppliers get the same advantage as well. As they transact with other customers, they can keep separate ledgers so that customers don't have insight into other customers' transactions. And so we start to see a platform that is much more focused on building enterprise-grade applications, especially applications with cross-organizational boundaries. Whereas Ethereum lends itself a little bit more to the consumer side of blockchain. If we look at a Hyperledger transaction, we see something very, very free-form. So this is a screenshot taken from a solution template around a car auction website. Folks could come register at this auction website and list a vehicle for sale or bid on a vehicle someone else is selling. And you can see in this screenshot, we've said there are 4 different properties of our users we want to keep track of. We want to keep track of their account balance, their email address, their first name, and their last name. So I get a very free-form data structure. And if I was solutioning a different use case, I might have something completely different here. All right, well, all this kind of naturally gets into a discussion about public and private blockchains. You'll often hear something like, oh, Ethereum, that's a public blockchain, and Hyperledger, that's a private blockchain. And unfortunately, these are very overused terms. And so this conversation can become confusing very quickly because we've adopted public versus private to talk about three completely separate things. If we're talking about a public blockchain or a private blockchain, we might be talking about the ability to add records onto the ledger. We might say that a public blockchain is one where many people can come add records to the ledger. And a private blockchain is one where only a few special people are able to do that. If we're talking about a public or private blockchain, we might not be talking about who can add records. We might be talking about whether the blockchain platform itself offers any kind of built-in permissioning features. Is it an anonymous platform, or is it one that tracks and maintains identity? Or we could use these terms public or private not to refer to the ability to add records or whether the platform itself is permissioned or not. We may be using that term to talk about the accessibility of the network itself. Is this blockchain platform running on a public network like the internet or a private network like the one that exists behind your corporate firewall? So all this is very confusing. If you're just having a conversation with someone and they say, I think we should use a public blockchain, what is it they're talking about? Are they talking about the ability to add records? Are they talking about an unpermissioned platform? Or are they talking about a publicly accessible network hosting the blockchain platform? Or are they talking about some combination of any one of those three? You can imagine the confusion in trying to discern what someone means when they use these terms. So let's back up and talk about what public and private really mean, and then we'll introduce some new terms that we can talk about some of these other considerations. So we'll begin by talking about a database. Databases have four primary functions, and if you've ever taken a course on relational database design, you've certainly heard about the CRUD functions before. In a database, there are four primary things I can do. I can create a new record, I can read an existing record, I can update an existing record, or if I want, I can delete an existing record. Well, in the world of blockchain, we intentionally remove those last two functions. And the only thing we can do in blockchain is create a new record or read an existing record. There is no ability to update and no ability to delete. So let's imagine a database full of customer data. Imagine you're one of my customers and you call me up because you've moved and you have a new shipping address. Well, in the world of a database, that's a pretty easy thing to accommodate. I'll simply go find your record and I will update your address. I will replace the old value with the new value. If you call me up later and you no longer want to be a customer, I can simply go delete your entire record from my database. If I was maintaining that same customer data on the blockchain, when your mailing address changed, I couldn't update your record. The only thing I could do would be to create a new record at the bottom of the ledger, indicating that your address was now different. Similarly, if you didn't want to be a customer anymore, I could never delete your data. The only thing I could do is add a new record to the end of the ledger, indicating you are no longer an active customer. So when we go to define who can do what in a blockchain solution, we're defining who can write data to the blockchain and who can read data from the blockchain. And we don't need to define anything more than that, because there isn't anything more to define. So the proper use of the terms public and private refer to the write portion. Who can add a record to the blockchain? Who can write data? And if we're using these terms properly, we would say that a public solution is one where relatively large audiences have the ability to add data to the ledger, whereas a private one is one in which only a small audience has that ability. The second function, who can read or consume that data, we use the terms open and closed to describe. In an open solution, very large audiences are able to read or consume that data. In a closed one, that audience is much smaller. So the proper use for the term public and private is always to talk about who can add data or create a new record on the ledger. Oftentimes, when people use the terms public and private, what they're really talking about is whether that blockchain platform is permissioned or permissionless. People generally refer to a permissioned blockchain platform as being private, and a permissionless blockchain platform as being public. Although for reasons discussed previously, I would strongly advise you against using these terms in this way yourself. The idea here is that if we have a permissioned blockchain, remember I have said a couple times, permissions are a prerequisite to identity. So any permissioned blockchain is going to be one that tracks and manages identity for you, that has some inbuilt functionality to track every transaction or data point back to an individual participant, either a human being or a line of business system. Permissionless blockchains like Ethereum and Bitcoin, we simply mean that term permissionless to refer to the fact that natively these platforms make no attempt to associate an end user to an account or wallet. And this raises the question of anonymity. How anonymous am I when I use the blockchain? And the answer to that is it really depends on what blockchain platform you're talking about. Anonymity is not a fixed target, but rather a scale. And we can think of this scale as forming a spectrum. And at one end of the spectrum, we have platforms like Bitcoin or Ethereum, which simply have no native inbuilt functionality to track things back to the end user level. Now, obviously, if you owe me some money and you send some money from your Bitcoin wallet to my Bitcoin wallet, I know now who the owner of that wallet address is. I've been able to manually associate that account or wallet back to an end user. So anonymous on platforms like that doesn't mean it's impossible, doesn't mean you're truly anonymous. It just means the platform isn't going to make that link for you. At the other end of the spectrum, we have platforms like Monero or Loki, which take many steps to intentionally obfuscate transaction details to make it very, very difficult to trace back the individual participants involved in any one single transaction. So just understand when you hear this term anonymous in the blockchain world, whoever is using that term could be referring to any point along this spectrum between not that hard to find out who the end user is, but the platform won't help me, to the other end of the scale where the platform is actively trying to thwart my efforts to figure out who the individual participants are. And then finally, remember, blockchains are just a protocol. They're just a set of rules that all the nodes on the network agree to follow. The rules that are followed have absolutely nothing to do with the size of the network that those rules are being applied to. Again, think of traffic rules. Traffic rules are the same whether you're in a very, very large city or a very, very small town or village. The rules don't change based on the size of the network. And this is where things can get really confusing, because when we talk about networks, we talk about public and private networks. Public networks like the internet are ones that everyone can get to, or very large audiences can get to. Private networks might be things like your corporate network behind your firewall. Networks that are gated and protected, and only small numbers of participants can access them. Well, we can run a blockchain on any network, regardless of the size. If you wanted to run an instance of Bitcoin on your corporate network behind your firewall, you absolutely could, because it's just a protocol. It's just a set of rules, and those rules do not change if the size of the network changes. So if we talk about a public or private blockchain network, we might want to make sure, hey, are you talking about something permissioned or permissionless? Or are you truly talking about the network? Because we can take a permissioned platform like Hyperledger, and we can run it on a public network like the internet. We can take a permissionless platform like Ethereum, and we can run it on your corporate network behind your firewall. So anytime someone talks about a public or private blockchain, drill in a little bit and ask them, what is it you're really talking about? Let's make sure we're talking about the same thing. And when you're talking about a blockchain, make sure you're using the right terms in the right places to avoid any confusion. All right, let's talk a little bit about some of the differences between blockchain on the consumer side and the enterprise side, because there are some pretty fundamental differences. Up until this point, a lot of the attention in the blockchain world has gone over to the consumer side, but the enterprise side is starting to catch up. And so if you look at how most people would describe a blockchain, if you asked them to describe what they hear about, which is something public, open, and permissionless, well, they'll generally say, hey, blockchain is a technology that gives you a decentralized ledger. And this ledger can store any type of data. This ledger is shared completely and totally with all the participants on the network. This ledger is, for all intents and purposes, immutable. The data on it cannot be changed, or not without significant time and cost and effort. The participants on our network are anonymous. We make no effort to trace back wallets or accounts to actual human beings or end users. And that means all of our data is fully transparent, because if I don't know who you are, there's no way for me to define and enforce permissions. We rely on group consensus, majority rules. If 51% or more of our network come up with the same result, we're going to go ahead and assume that that result is true and accurate. And finally, we have smart contracts. We have the ability to use blockchain as a workflow platform to make it respond to certain types of transactions and events. All right, so now imagine that you're a CTO, you're a Chief Technology Officer, and you're thinking about a solution for the enterprise space. Think about if I describe blockchain to you in these same terms. Ask yourself, as a CTO, as a technology executive, are these desirable qualities or undesirable qualities? And you see, we kind of come away with a mixed bag. For example, if you're a CTO and I say to you, I can give you a decentralized ledger and this ledger can store any type of data, is that a good thing or a bad thing? Well, you're likely to say that's a pretty good thing. But when I tell you that that ledger will be shared completely and totally with all the nodes on the network, that's when you're likely to pull back a little bit, because as a business executive, you don't want to share all your data with everybody all the time. You want to be able to control where is it stored and who can consume it and what can they do with it. All right, well, if I told you this shared ledger is immutable, Nobody's going to be able to hack it or change it or put anything untruthful on it. Well, as long as you're running a legitimate business, that's likely to be something of tremendous value to you. However, when I tell you that this network is going to be anonymous and fully transparent, that's probably where you're going to push back. Anonymity and full transparency are the two enabling components of public permissionless blockchain. But when we get into the enterprise space, anonymity and full transparency are likely the two least desirable qualities to have in a solution. Users do not want, business users do not want their users to be anonymous. They want to know who they are. And the reason they want to know who they are is, again, because they don't want all their data to be fully transparent. They want to control and define who can see what parts of their data and what can they do with it. Of course, smart contracts still add a lot of value, so that's definitely a win there. And a very interesting thing happens with group consensus, and that is if anonymity goes away, if I now know who the participants on my network are, well, that means I know who the participants in any individual transaction are. And if the participants in a transaction are able to reach consensus between themselves with whatever rules they want to use, the rest of us should just be able to take their word for it that what they agree on represents the truth. Think about if you and I have a transaction together, and at the end of that transaction, you and I are 100% in agreement with the outcome. Well, if that's the case, the rest of planet Earth should just be able to take our word for it that what we agree on represents the truth between us. And so it's a very subtle but very powerful shift. When we get into the enterprise space, we can replace group consensus with a model known as participant consensus. Now, all of this is really driven around solving a certain problem in the enterprise. That is a problem known as the traveling salesperson problem. And this is a famous problem in mathematics and computational science. It's an example of something known as an NP, or non-polynomial time problem. And that's just a fancy way of saying it's a really tough problem to solve, because any NP problem is one where if you want to be able to calculate an answer in a fixed amount of time, you're going to need exponentially more computing power to do it as you scale up the size of your data set linearly. So these are problems that become incalculable very, very quickly. And one of the best examples of an NP, or non-polynomial time problem, is this problem known as the traveling salesperson problem. And the problem is this. Imagine that you're a salesperson and you are planning a trip, and you have one different customer in each city. What is the shortest trip you can plan, the shortest distance you can cover, where you visit each customer once and only once? And the idea here is if you have one customer in one city, you have no problem because you have no trip to plan. If you have two customers in two cities, you still have no problem because it doesn't matter whether you go from point A to B or from B to A, you're still going to cover the same distance. If you have three customers in three cities, you still have no problem because no matter which way you go between those three cities, you will always draw the same triangle and thus cover the same distance. But when you get to four or more, things start to get problematic. And the amount of computing power you need to calculate the shortest distance between 5 cities is exponentially more than what you would need to find that same shortest distance between 4 cities. What does all of this have to do with enterprise blockchain? Well, our modern business networks are starting to resemble this traveling salesperson problem. Let's walk through a little example. Let's say that you're the chief technology officer at company A, And Company A has just started doing business. You're a brand new company. So in the beginning, things are nice and simple. You are just transacting with the local bank. And so that means as the CTO at Company A, you have to worry about managing the integrations from your internal systems to the systems of the bank. And you have to help support the integrations that the bank is making back into your systems. But that's nice and easy. Well, then time goes on and we get some more participants in the mix. We have some auditors step in. And now as the CTO, you have to worry about managing the integrations from your internal systems to those of the bank and the auditors. You have to help support the bank and the auditors integrate their systems back into yours. The bank is going to have to integrate their systems with the auditors, and the auditors are going to have to integrate back in with the banks. So we add one single participant, but we add quite a bit of complexity. Let's keep going. Let's say that we get another organization onto our business network. We get some attorneys involved. So now, as the CTO of Company A, I have to worry about maintaining my integrations to the bank, the auditors, and the attorneys. I have to support the integrations that the bank, the auditors, and the attorneys are making back into my systems. The bank additionally has to worry about integrating with the auditors and the attorneys. The auditors have to worry about integrating backs with the banks and the attorneys have to manage their integrations with the banks and the auditors. Wow, just by adding one more entity, we've added much more complexity. Let's take it another step further. A second company gets involved, a vendor, a supplier. All right. Well, now I've got to manage my integrations to the banks, the auditors, the attorneys, and my supplier. I have to help support integrations back into my systems from the supplier, the bank, the auditors, and the attorneys. The bank has to integrate to the auditors, the attorneys, and my suppliers. The auditors have to integrate with the bank, the attorney, and the suppliers. The attorneys have to integrate with the suppliers, the auditors, and the bank. My suppliers have to integrate back to me with the bank, the auditors, and the attorneys. And you can very quickly start to see every time we add one new participant into this ecosystem, the amount of complexity we get in the middle increases not linearly, but exponentially. And this has led to a very, very significant problem in the modern business world. In many areas in the business world, we are artificially limiting the size of our business networks only because we cannot continue to manage the complexity if we continue to scale these networks up. And there are people in certain industries you can talk to about this problem who will know exactly what you're referring to. For example, if you have any friends or family members or acquaintances who are working in pharmaceuticals, especially in drug discovery, ask them about this problem and they will tell you, absolutely. We could find treatments and cures to our most pressing diseases and ailments if only we were able to work with and collaborate with more independent researchers, more universities, more government agencies, even more of our own competitors in the pharmaceutical space. The only reason we don't scale up the size of our business network is because it would be impossible to manage the corresponding complexity that would come along with it. Part of the business proposition or value proposition behind enterprise blockchain is removing this complexity. And if we can get all of these participants in a business ecosystem or on a business network to integrate to a common blockchain platform, then we can reduce the impact of this problem. And now as the CTO at Company A, the only thing I have to worry about is managing the integrations of my internal systems back to that common platform. Today, traditionally, we do that with a lot of one-off integrations and rigid couplings. And if any of the underlying systems on either side change, everything breaks. Whether or not enterprise blockchain is the platform to finally deliver on this long-promised dream will remain to be seen. But that's some of the business value that is starting to be explored with blockchain and decentralized technologies currently. And all that sets the stage really well for our next section, where we're going to dive in and take a deep look at blockchain use cases. Not just where this technology is being used and who's getting value out of it, but maybe more importantly, how do you know when to use blockchain? How do you know what are the right and wrong use cases? What are the simple litmus tests you can do to tell yourself whether it's worth investigating blockchain further or whether you found a use case which is better addressed with conventional technology? So, really interesting stuff coming up. Be sure to tune back in for our next section where we take this deeper dive into blockchain use cases.